Well, hello and welcome to some more Just Enough Computer Science. Today we're going to look at how to wire in and work out how integrated circuit chips work. Now then, before we do that, it is worth saying in the last video you may have seen me use jumper cables, these things, and they are very useful, but they very quickly turn, as you will have seen, a breadboard into an absolute mess. So as a vastly preferable solution, if you're going to even faintly semi-permanently wire things in, you want to use some solid core, in this case 22 American wire gauge cables, and I've got various different colours going on here that I can use. You can cut them exactly to length, which is what I have done here. So what I'm going to do is I'm going to connect the top and bottom power cables together, like I did last time, but slightly more neatly, like so, and like so. Okay, and that means that when I plug in my power supply, which is here and here, I will get power to everywhere on the board which I need it to get to. Now, I've already done some setup work here. You can see I've got a resistor, an LED and a switch, and again you can see I'm playing nicely this time. I've cut my resistors legs to a sensible length, and I have made it all look as neat and tidy as possible. Now for this end, what I'm going to do is I'm going to put some more jumpers. Please note I'm using red and black for power cables, but for individual things I'm using different colours. In this instance I am using blue, but there's no particular reason why you couldn't use a different colour. What I'm doing is I'm wiring the top of the chip high to the power rail, like so. Ooh, assuming I can get it to go in. And I shall do that to the other switch as well. And this is going to allow me to do a little bit of exploration of the logic chips that we're going to look at. Oh, hello. There we go. Right. So if I power this board on, with a bit of luck, can you see when I push this button, I'm going to get a high signal there. When I push this button, I'm going to get a high signal there, and we can see what the effect is going to be. So, IC chips, they all have codes on them, and we're going to look at a selection that are called the 7400 series. These are they. I don't know if you can see, it's almost impossible to pick up on a camera, but they have writing on them. Okay, so this particular chip is a 74HC04. This particular chip is a 74HC08. Again, I've got absolutely no idea if you can see that or not, but just take my word for it that it's written on them in very small handwriting. The 7400 series is a series of logic chips. They were invented a long time ago. They're very useful, and this is how we're going to find out about them. The HC bits, you can get them in loads of different flavours. The two main ones you might see are 74HC or 74LS. But a 74HC04 will do the same thing as a 74LS04. And a 74HC08 will do the same thing as a 74LS08. It's all about the technology used in them. That's not something we need to explore too hard at this moment in time. So, how do we go about looking at a chip? Well, the first thing I'm going to do is I'm going to plug it into my board, and then I can look at how I'm going to wire it up. And for that, we need to go across to our data sheet. This here is the data sheet for the 74HC04, and there's all sorts of information. It's several pages, but the stuff we're interested in is here. So, firstly, we've got a pinout, which will tell us what pins are connected to what, and secondly we've got a diagram which should tell us roughly what is inside the chip. Now then, it should be noted, let's see if this will work. Oh, hello, look at that, I have myself a working mouse. Okay, so it should be noted that there is a little cutout, little notch in this end of the chip. And if you can see, I've set up my chip so the notch is at the same end. And the first thing we can see is VCC and ground. VCC means the power, the high connection, and ground is the low connection. So we've got the chip's got to be powered somehow. So let me just disconnect power from this circuit, and let's wire in this particular chip. So this particular chip, pin number 14, the extreme top left, goes up to the positive rail, like that, and pin number 7, the bottom right, goes down to the ground. You can see now why it's useful to have both ground and power on both sides of the board. Let me just get this in. Sometimes they're a bit difficult to wrestle in, but there we go. Okay, so now our chip has got power. And if you have a look, if we go back to our data sheet, you can see that we've got 6 of the same thing on this chip. A1 goes to Y1, A2 goes to Y2, A3 goes to Y3, A4 goes to Y4, and so on. So we only need to look at, let's say, A1 and Y1. So let's have a look at that. A1 is an input, Y1 is an output. So let's take one of these switches, for example this one, and we will plug it in, and we will plug that one into A1. And then I've got here another resistor combo. So I shall take the Y1 output and I shall plug it into the output of that. And when I plug this in, let's see what happens. Okay, well, immediately our output goes high, it lights up. So what happens if I push the button for the input? It goes low. So the 74HC04 chip is an inverter. Whatever the input is, it just does the opposite. So how can we record that? Well, let's write it down on a piece of paper. Here we go. So in my notebook, I'm going to write down that the 74HC04 chip, I'm going to draw a picture, looks like A, doesn't it, HC. I'm going to draw a picture of the logic gate, and we called the inputs A and Y, so let's call them A and Y, and we say A, when A was 0, Y was 1, and when A was 1, Y was 0. Fantastic. So that is our first chip. What I'm going to do now is I'm going to power it off. I'm going to take out this chip. I'm going to swap it in for our next chip, and we'll see what that does. Right, our next chip is the 74HC08. So let's write it down, 74HC08. Okay, and this time let's go and have a look at the data sheet. Here it is. You can see we've got the same VCC and ground. That's the nice thing about these chips. So I don't need to alter those. They're already done. But also, I need 2 inputs. I've got input A and input B in order to get output Y. So let's draw a little table. Okay. Like so. Okay, and now let's go and have a look at our pin out, and we can say A1 is pin 1, B1 is pin 2, Y1 is pin 3. Again, we don't need to look at 2, 3 or 4, it's just 4 of the same thing. So, let's have a look and see. So that means that I need A1 to go into pin 1, A2 to go into pin 2, and the output is going to come out of pin 3. And we'll stick that again into our output. Well, let's power that up and see what this one does. Okay, well, not a great deal as it stands. So if I push one button, yeah, nothing happens. If I push the other button, nothing happens. If I push both of them at once, it lights up. So this thing is called an AND gate. So let's go back to our notebook. We're going to draw a picture of the AND gate, like so. Okay, now let's have a look and see. Now we've got four options for our switches A, B. We've got them both, let's have a look, we've got them both off. We've just got switch B on, we've just got switch A on, and we've got both of them on. Now when they're both off, Y is off. When just B is pushed, Y is off. When just A is pushed, Y is off. And when they're both pushed, Y is on. So that's quite a good tip if you want to have a look at making sure that two things are high before something else happens. Okay, fabulous. Let's crack on and swap out for our next chip. Right, back to our data sheet. And if we have a look at this one, it's laid out slightly differently, but it's wired up in very, very much the same way. Look, we've got pin 14 and pin 7, so we don't need to change those. And we don't even need to change the jumper cables because A1, B1 and Y1 is going back to our circuit, exactly what we are expecting to see, A1, B1 and Y1. So we can just power this up and see what happens. Now, before we do anything, let's make sure we have our list 74HC. This one's 32. We'll draw ourselves a little table like that. Okay, again, we can do that. And again, I can draw myself a quick diagram. The chip is represented like that. Okay. So, let's have a look. With both buttons off, which is 0, 0, we get a 0. With just button B pushed, we get a 1. With just button A pushed, we also get a 1. And with both of them pushed, we get a 1. So this one only works if A and B are pushed, so that we call that an AND gate. And this one works if A or B, or indeed both, are pushed, so we call that an OR gate. All right, time to swap out for the next chip. Okay, our next chip is the 74HC00. 74HC00. I'm going to draw what I see on the data sheet, which looks an awful lot like our picture of the AND gate, but it's got a little circle at the end of it. So again, let's draw up our little table, A, B and Y. Okay, and again we've got a choice of both off, just B on, just A on, and both of them on. Okay, let's power up and see what happens. Okay, oh, I should have said, sorry, let's go back to our data sheet just for a second. I should have said, let's just double check. Yes, the VCC and ground are the same. Yes, A1, B1 and Y1 are the same. Let's go back to the circuit now. You should always check. I know these are the same series. I know that you can make assumptions, but let's just double check. So, with them both off, Y, oh sorry, is on. If I push button B, Y remains on. If I push button A, Y remains on. And if I push both buttons, Y goes off. So, if you have a look, this is exactly the same as, this is the exact opposite of the AND gate. The AND gate only came on when both buttons are pushed. This one only goes off. So it's an exact opposite. And you can see it's an AND gate followed by a little circle. It's the opposite of an AND gate. We call this a NAND gate. Stands for not AND. So, by the way, this first one, an inverter, it's technically called a NOT gate. Okay, so you've got NOT, complete with a little circle, you can see. We've got AND, we've got OR, and now we've got not AND or NAND. I wonder if you can guess what the last chip is going to be. Let's have a look and see. Right, let's go back to our datasheet and have a look. And this illustrates the importance of checking the datasheet. Firstly, we can see that this is, in fact, what is it? It's a 74HCO2. Okay, and we can see that it looks like an OR gate, but it has a little circle at the end. Okay, which I wonder if you can guess how this is going to work. I'm sure you can, to be fair. Not very surprisingly, this is called a NOR gate, not OR. Okay. Now, go back to our datasheet for a minute. This is why it is important to check. Look at our pin assignment. Okay, in this one, instead of having A1, B1 and then Y1 output, the Y1 is the first pin. So that is quite important. Okay, so we need to do a little bit of pin rearranging. It is always worth checking the datasheet for the pin outs. Okay, let's see what happens. I wonder if you can predict it. Okay, with both of them off, I wonder if you can see that. Yeah, with both of them off, the output is high. With just B high, the output is low. With just A high, the output is low. And with both of them high, the output is low. In other words, it is the exact inversion of an OR gate. So hopefully what we've learnt from this, I mean, we are actually going to use some of these gates, but in general, the point is, in order to understand how a chip works, check the datasheet, read it and understand it, and just connect things up as you go. Now then, the next video, we're going to have to go away from practical electronics, and we're just going to do one more sort of slightly theory-based video, which is going to be about the delights of binary and hex. So I shall see you next time for Just Enough Computer Science. Goodbye.